Okay, Unit 5B review. I'm not going to do every problem. I'm just going to do the ones that I have selected here. And so I broke it down by section number. Again, the review itself, I broke down by section number. So I'll be doing these problems. So I already have them written down. You should have the review. I'm going to go pretty swiftly through these. Remember, you can rewind as you need to. So here we go. We have 5.6, number 1, part B. We're just going to find the inverse of this. So the first step, replace f of x with y. That doesn't change the right-hand side. Now, to actually do the inverse, the y becomes x, and the x becomes y. Okay. Now we're going to solve for y. See how y is over here now, and we're going to solve for it. The first thing we want to do is subtract 4. Like that. Why do we subtract 4? Because those cancel. On this side, I get x minus 4 equals y squared. How do we undo the power of 2 on the y? Because we want to get y by itself. So to undo the power of 2, we take the square root of this side. What we do to one side, we do to the other. Because I introduced a square root on this side, you gotta put a plus minus before that square root. Alright, let's see what happens. So what happens on the right side with the power 2 and the square root? They cancel each other out, leaving you with a y. On this side, I have plus or minus the square root of x minus 4. We're going to go ahead and just turn that around so it becomes a y equals. So I'm not changing anything on this step. I'm just rewriting it like this. And then on the quiz, and I think on this sheet as well, it's asking if it's a function or not. Because of the plus minus, this is not a function. Okay. So there's your inverse, and that answers the question, is the inverse a function? And it's not because of the plus minus. All right, let's go ahead and do these. We have the cube root of 12. We want to rewrite this one using, in this form, basically, right? So all we do is we solve the 12. Now the power on the 12 is a 1. So my new power is 1 over 3. The power over the root. That's it. Don't overcomplicate it. We're going to go backwards here, going from this form to this form. So I have 5 to the power 1, which is just 5, so I'm not going to put the power 1 there. And then the bottom number is my roots, so I'm going to have the 4th root of this. That's it. This one we're going to calculate. Let me grab my calculator. I did finally bring one of these with me home, so we're going to calculate the 7th root of 1,695. So turn this on, type in 7, see if this shows up better. There we go. 7, hit the math button, go down to the 5th row, and then 1695. So our answer, we're going to round to 2 places. This will round to 2.89. Sometimes the calculators don't display what we typed in just like that. So I'm just going to show you something real quick. You hit the same buttons, but it might look different up here. 7, math, go down to number 5, hit enter, and we're doing 1695. And we got the same answer, but it looks a little different than the first time I typed it. But we got the same thing. All right, let's keep going. We're going to solve these 3 problems. Part A, all we have to do, because we already got x by itself, is we take the cube root of both sides. Why did I choose the cube root? Because we're trying to undo a power of 3. What I do to one side, I do to the other. The 3 and the power of 3 and the cube root cancel, and you get x. The cube root of 125, 3, math, go down to the 5th row, type in 125, hit enter. So the cube root of 125 is 5. Do I need a plus minus here? Well, look at the root. This root is odd. Because it's odd, I don't need a plus minus. So that's it. On this side, I don't have the x by itself. I need to divide by 5 first. Let's go ahead and do that. So I get x to the power 4. That's left over here. And what's 405 divided by 5? It's 81. Okay, now how do we undo the power of 4? We take the fourth root. So on the right-hand side, sorry, on the left-hand side, the power of 4 and the fourth root, they cancel, so you get x. The fourth root of 81, 4, math, down here, 81. So the fourth root of 81 is 3. Now I'm going to leave a little space because I'm going to look at my roots, and because we took an even root, I need a plus minus here. This is a very common mistake, by the way. Remember, if it's odd, no plus minus. If it's even, you need a plus minus there. Let's go ahead and do part C real quick. First step, subtract 36. Cancel. X to the 6 equals 100 minus 36 is 64. Now I just take the 6th root of both sides. The power 6 and 6th root cancel. X equals whatever this is. I'm going to go ahead and type it in. 6, math, down to the 5th row, hit enter. Type in 64. And hey, it's 2. Even root. So I'm not going to just put 2 here. I'm going to put plus minus 2. Let's keep going. This one, I'm going to add the exponents together because I'm multiplying the 5s. So when you multiply two of the same thing, you add their exponents. Now, a common mistake here is sometimes when people say 5 times 5 is 25. That's true if that was just the problem. But that's not what the problem is. So our answer is going to be 5 to some new power. We're not going to do 5 times 5. We're only going to add the exponents. So what is 3 halves plus 1 half? Well, we need a common denominator. Do we already have one? Yes, we do. So all we do now is we keep our common denominator. 3 plus 1 is 4. So our answer is 5 to the 4 over 2. Sometimes you cannot go further because you got to look at the fraction and say, can I reduce that? And so maybe on the quiz it can reduce, maybe it can't. If it can't, you leave it. This is your final answer. This one, however, 4 divided by 2 in the exponent is 2. And hey, isn't just 5 squared? That's what? 25. All right, let's go down to this one. This one we have a 40, an x to the 9, and a y to the 7. Notice how I underline them. They're all inside this cube root, so I'm going to give them all their own cube root. Like this. Okay? That should be pretty easy. Just separate each one into their own roots. In this case, a cube root. If it's a square root, they all get their own square root. Now, because we're dealing with cube roots, I want to think about my list. Perfect cubes. 1, 8, 27, 64, 125. I'm going to stop there because, well, I'm trying to find, either is 40 on the list, it's not, so find a number that goes in the 40 that's on the list. 8. 8 goes into 40. 8 goes into 40 5 times. So what we're going to do is we're going to split 40, the cube root of 40, into the cube root of 8 and the cube root of 5. Because eventually we could take the cube root of 8. I'm going to go ahead and bring these guys down. We'll take care of these in a second. So what is the cube root of 8? You can look at this list and figure out it's 2. If you don't believe me, you get this thing out once again, and hey, it's 2. The cube root of 8 is 2. So this becomes 2. 5 is not on my list, on the original list I wrote. So I'm going to have a cube root of 5 in my final answer. So I brought this down as 2. This became 2. This came down. So now I want to take the cube root of x to the 9. Well, this is where you ask yourself, how many times does the root go into the power? So how many times does 3 go into 9? 3 times. That means you put an x to the 3rd right here. Now, was there any left over when you divided 3 into 9? No. So you're not going to have any leftover x's inside here. Let's do it again. Let's do it with the y's. So we took care of this. Let's do it over here. How many times does 3 go into 7? Well, it goes in there twice. But when it goes in there twice, you still have 1 left over. Where does that leftover go? Right here. That's how you do it. By the way, remember, this was a cube root problem. The root was 3. If on the quiz it's a square root, you don't want to use this list, what list would you use? You would use this list if it's a square root. Okay? The list is on the board. You know where it is. All right, two more problems. I'm going to try and keep going here. We're going to graph this. This is a square root function we're graphing, so it should take on this shape right here. Okay? So this is my h. This is my k. Because h is -3, h lies, so we're going to be going to the right 3. You would think that it would be -3, be to the left 3, but because it lies. And then the +1 tells us we're moving up 1. So let's go ahead and draw a graph real quick. 1, 2, 3, 4. Let's go 4 in every direction. Alright, so let's go right 3 and up 1. So we're going to start at 0, 0, go right 3, up 1, put a point there. We have no vertical stretch. It's a 1. So that means we just go up 1 over 1 to get our second point. Draw your graph. That's the graph. Okay? Domain and range. I'm going to abbreviate it D and R. So domain, the graph starts on the x-axis at 3, and then it keeps going after that. So your domain is x is greater than or equal to 3. For the range, on the y-axis, the graph starts at 1. See that? It starts at 1. That's the lowest point. So your range is y is greater than or equal to 1. Because once you hit 1, the graph goes up forever. And so it hits all these numbers on the y-axis. Last one, we're trying to solve for x. Notice that we have an x on this side and an x on this side. But the x is on this side is in the square root. So we need to get it outside of that square root. How do we do that? Well, how do you get rid of a square root? You take the power of 2 on that side. Now, what you do to one side, you got to do to the other. And how do you do it on this side? Well, you put this whole side in parentheses and raise it to the power of 2. So let's go ahead and let's just see what happens to both sides, because something, happens to both sides here. On the right-hand side, this is easy because the power of 2 and the square root, they cancel, leaving you with what's inside, which is 3x. On this side, a common mistake is people think that x minus 6 to the power 2 becomes something like x squared minus 36. They think you distribute the power. That is not what you do. What you do is you write x minus 6 squared twice, like that. But look at what you have here. You can FOIL this. Remember, FOIL. You just multiply these. So I'm going to make a little room here. We're still got 3x on this side. Well, x times x is x squared. X times -6 is -6x. -6 times x is -6x. -6 times -6 is positive 36. Right here, I have like terms. Which, -6 minus 6 is -12. This looks like a quadratic, which means I want to move this over here because I want to get it equal to 0 because we're probably going to factor. Let's go ahead and subtract 3x from both sides. So I get minus 15x plus 36 equals 0. So now we're in that form where we can factor this. So what times what is 36? Let's think about this real quick. 1 times 36, 2 times 18, 3 times 12. And actually, 3 times 12 is interesting because if you had -3 and -12, that could add up to -15. And in fact, I think that's what we're going to be using here. And it works, right? Because remember, that's how factoring works. -3 times -12 is positive 36. -3 minus 12 is -15. Now, from each factor, what do I get? From here, I get x equals 3. From here, I get x equals 12. You know the little trick that -3 gives you positive 3, -12 gives you positive 12. Now, these are both our solutions, except one of them might not actually work. So let's see each one. I'm gonna try and fit it right here. So I'm not gonna circle these yet because I have to check these. I'll switch to a different color so it's not all blending together. So let's try 3. Let's try 3 out right here. Let's show the work right here. So we're plugging 3 to the original problem before we even squared it. So it was x minus 6. That becomes 3 minus 6 equals the square root of 3 times x. Well, that's 3 times 3, which is what? We know that's 9. And then on this side, what's 3 minus 6? That's negative 3. What's the square root of 9? 3. What we're looking for is, when we plug our solution in, does it make what we plugged in equal to each other on both sides? Well, is negative 3 equal to 3? No, it's not. Which means we do what with our solution x equals 3? We reject it. It's what we call extraneous. Alright, let's go ahead and try x equals 12. Remember, we're just taking 12 and plugging it back into the original problem before we even did the powers of 2. So we're plugging 12 in. So we have 12 minus 6 equals the square root of 3 times 12. 3 times 12 is 36. I'm doing a little mental math here. I think you can follow along with that. Anyways, 12 minus 6 is 6. The square root of 36 is also 6. What does this tell me? If I have a number equal to the same number, what does that say about my solution? It is actually a solution. That's how you do it. Sorry, no math joke. There you go. Good luck.